So again, the lesson today is on logarithms. And my goal today is that by the end of the period, you will know what a logarithm is and be able to work with logarithms. But to understand a logarithm, we're going to start with what we did before, which is if I give you an exponential, how do you know 2 to the exponent x is an exponential function? Because the variable's in the exponent. How do I know 2 to the x is an exponential function? Because the variable's in the exponent. Do you know what this symbol means when I put a little -1 there beside the f? Inverse. So what I'm asking you to do is, can you find the inverse of this exponential? How do we find the inverse of a function? What do I do? So instead of f at x, what do we write down? And instead of x, what do we write down? And then, once we set it up, now what do we do? Well, you solve for y, right? Do you think square rooting both sides would get y by itself? What do you think we need to do in order to get y by itself in order to solve for y? X root. I know, right? Does it feel a little confusing? Because you are solving exponential equations. How did you solve that equation like 10 seconds ago? What did you do? You made the bases the same, right? Is there any way to make the bases the same? What are the bases here? X and now what? Can you see how we're stuck? Like algebraically, what are we going to do? We're going to add, subtract, multiply, divide, square root? Do any of those operations that we know work here? No. I have to give you a new operation. Guess what the new operation is called? What? A log? Do you already know it ahead of time? So, I have to write it as a logarithm is what's going to be able to inverse an exponential. This is brand new, isn't it? Yes. Believe it or not, to solve for y, we write it as a logarithm. Y equals the logarithm of x base 2. Isn't that crazy? Something you've never, ever seen before. But what I want to get to today is to understand this. If I ask you, what is a logarithm? You are going to say, it's the inverse of an exponential. You're going to say those two words. Like, what's the inverse of adding? What's the inverse of multiplying? And today you're going to say, what's the inverse of an exponential? And you're going to say, logarithm. So I don't have more work to do on here other than the practice we're going to do. So step 1 is I introduced a brand new mathematical operation to you called a logarithm. Do you know for years you've stared at a calculator?
Yes, I've seen.
And have seen the letters LOG, and you thought maybe it's like somebody in forestry or something? You know, if you're taking care of trees, maybe that's why you have a log. Get it? Log button. Because maybe that. Did anyone wonder why that button existed? You know what? The dreams come true, right? Like Disneyland. Pinocchio and Giuseppe. Sometimes dreams come true. So, I am going to teach you about logarithms. And part of this is knowing how to use your calculator. All right. Let's go to the learning packet. So, first question is, what is a logarithm? And what two words am I looking for? So, if somehow the two words that come out are inverse and exponential, then you're starting to understand the word logarithm. Here, is a logarithm? There are three parts to this logarithm. So first of all, we often shorten the word logarithm and just say the word log. Is that okay? Rather than always saying the word logarithm. So we would read this as log A base B. So I want you to notice, you know that an exponential has a base? A logarithm also has a base, just like an exponential. So I'll say it again. This is log A base B equals x. You think you can think that in your head? This is log A base B equals x. You believe that in your head? Now, a logarithm can be written as an exponential, and an exponential can be written as a logarithm. We can go back and forth with two different forms. So, what's the exponential form of what was just written down? So, I want you to notice some parts here. Obviously, B represents the base, so that's the base of the exponential. So the base of the logarithm matches the base of the exponential. Do you see what it's equal to? That becomes the exponent. And do you see what's inside the logarithm? That becomes the answer, or the output. So, as we work through something brand new today, I'm going to keep reminding you of things that you forget because it's Monday morning, right? So first, what's a logarithm again? Inverse of an exponential. There are three parts to a logarithm. Do you see the three parts I looked at? One part of a logarithm is called the base. The other is the answer or output. And then the last part there by itself is the exponent. And it's practice that reminds us how to go back and forth. All right. There are different types of logarithms. One type of logarithm is called a common logarithm. So a logarithm that has a base of what? You listening? 10 is called a common logarithm and can be written without any base. So if you see a logarithm, see how it's written with a base of 10? That can actually just be written as log x. And we don't have to say log x base 10. So when there's no base that you see, there's still a base, and that base is 10. Now, our number system is base 10. That's the connection. So this is log x, which means the base is 10. And what do we call a logarithm that has a base of 10, where we just have to write down log and whatever's inside it? We call that a common logarithm. All right, let's practice a little. Now, can you write each equation in exponential form? So let's start. The easiest place to start with a logarithm, first of all, I need to know that you believe you can read this properly. Like Nancy, if I said read this, what would you say? So I like how you said it. I would read log 49 base 7 is equal to 2. Try it again. I would like you to say log 49 base 7 is equal to 2. Awesome. Hi, Anthony. So, can you recognize the base of the logarithm? What number is it? What number is the base of the logarithm? 7. Can you write down a big 7? Because that 7 is going to be the base of the exponential. Did you do it? Yay. Next, I need you to identify what's the logarithm equal to. And then we write down equals, and then on the other side is going to be the output or the answer. So inside the logarithm is, and of course 7 squared is equal to 49. It fits, right? Okay, let's try number 2. Dahlia, can you read number 2?
Log base 2 is the base of 2 is equal to 5.
Beautiful. You know, the first thing I want you to identify is the base of the logarithm, which is 2. What number is the exponent? And then what's the answer? Got it, right? Try it again. Number 3. You're catching on. Clarissa, how do I read number 3?
Log 1,000 with the base of 9 equals 3.
Right, and when it's a base of 10, we don't even need that cute little part at the end. We can just say log 1,000 equals 3, and we already assume and know that the base is what you said. So what did you say the base is? So I write down 10. What's the exponent? And that's equal to 1,000. Are you with me, Kim Cruz? Are you already like trying it on your calculator on your phone? Is that what I'm seeing? That's kind of cool. We'll learn. Kim Cruz, read 4 for me.
So log 1 over 64 base 4 equals -3.
All right, how do I write that as an exponential? What's the base?
1 over 64
No, what's the base? What's the base? You got 3 chances and then you strike out. I know. Do you know why you're not knowing it? I won't say it out loud. So, the base is 4. What's the exponent? Yeah, -3. And what's the answer? All right, let's keep trying, right? Folks, this is brand new. Kay, read it for me.
1, 2, 3,
Okay, what's the base? What's the exponent? 1/3. And what's the answer? What's the answer? 2. Done. See how this is simple, right? Corey, read it.
Log base 9.
Nope. Try again. Read it again. Want me to read it first? Log 27 base 9 is equal to 3 over 2. Go!
Log 27.
Yeah, say it like you mean it later so I can hear it. Go for it.
Log 27 base of 9 equals 3 over 2.
Equals 3 over 2. Good. So how do I write this as an exponent? What's the base?
Base is 9.
Yay. What's the exponent?
3 over 2.
Yes. And what does that equal to?
27.
Perfect. All right. We're going to go the other direction. What does that mean? We're going to start with an exponential and write it as a logarithm. Eduardo, how do you think I should write 5 squared equals 25, but write it as a logarithm?
Log 25 base of 5 equals 2.
So, it's log 25 base 5 is equal to 2. Perfect. Do you notice the bases match, don't they? And what we have to think about is what number represents the exponent or what number represents the answer part and putting it together. Here we go. Lizbeth, how do I write that as a logarithm?
log 0,
Say it again.
log 0, no, log 8, and then
You get one more chance, Lizbeth.
1,
You ready? Log 1 base is equal to?
yeah,
You said that? I knew you did. Genesis, write number 9 as a logarithm.
log 1 over
Log 1 over 81, yep. Base?
base -4,
No, base.
3,
See, notice the bases match, right? That should never be that's the least confusing part, right? Is equal to? Perfect. Keep practicing. 10. Richard.
Log 12 base 20.
We're going to try again from the beginning. See, we're all learning today. Log what? No, let's try again. 2 strikes. Let's hit that ball. One more chance. Log. You're going to say it again, aren't you? You're going to say log 12 again, aren't you? All right, one more chance. He knows it. You don't think he knows it? He's like spinning right now, but he knows it. You ready, Richard?
Log 2
Log 2 root 3 base.
base 12.
Yes, equals? Perfect. Number 11. Marilyn. One tenth base. Log 1/10 base 10. Do I need to write 10 there? No. So it's just log 1/10 equals? Perfect. Number 12, Chris Smith.
Okay, it's log 8.
Yep.
Log 8 out of base 16.
Yes. Like it. All right. So the first skill is if you have a logarithm, can you write it as an exponential? If you have an exponential, can you write it as a logarithm? How many parts do you have to worry about? 3, and when you practice, you'll actually remember it. Period. The first time you see it, it gets more challenging. Jocelyn, ask me.
How come you don't have like 10?
Good question, because back up here, if it has a base of 10, it's called a common logarithm. A common logarithm is written with an empty base. Even though we know the base is 10, we leave it empty to make it quicker to write down and work with. But we know when it's empty, the base is 10. And the reason it's special is because our number system is base 10. So it's the special kind of it's called a common logarithm. It's one that we can quickly work with. And it's one that's on your calculator that has log. That is a logarithm that's base 10. Good question. Hey, number 13. Next skill. Do you know how to evaluate a logarithm? So if you're given a logarithm, could you tell me what the answer is? What's log 36 base 6? Are you ready to listen? When you evaluate a logarithm, you're looking for the exponent. When you evaluate a logarithm, you're looking for the exponent. When you evaluate a logarithm, you're looking for the exponent. Thomas, what exponent would make that true? Thomas, what's the base?
Oh, that's 6.
Right. I don't know the exponent because when you evaluate a logarithm, you're looking for the exponent. But what's the answer? It's 36. So can you put the pieces together? 6 to what exponent is 36? What exponent is it that's missing? Because 6 squared is done, right? Simple. So when you evaluate a logarithm, that was like the loudest ding from a phone. When you evaluate a logarithm, what are you looking for, Michael? The exponent. When you evaluate a logarithm, what are you looking for? The exponent. Let's look at number 14. Alyssa, how do I evaluate that logarithm? What am I looking for? Yes. So what exponent makes it true? I'm listening. I don't even know what that cough was. I'm listening to you. What is the exponent that's missing? So 2 to the exponent 8 is equal to 128. So when you evaluate a logarithm, what are you looking for? The exponent. Turn the page. Oh, it's going to get more fun, more fun, more fun. Pedro, you ready? All right, here we go. Number 15, how do I evaluate a logarithm? We're looking for that. Corey, listen to me, not the calculator. We're getting, the next part is calculator, I promise. Okay? I promise. So, Pedro, here we go. -2. Are you telling me that you're that smart? That when you don't see a base, the number is 10, and the answer is 1 over 100, so the exponent must be, because 10 to the -2 equals that, right? Man, you're good. Kaylin, number 16. How much have you been listening to over the last 10 minutes? Like a lot or little? You want some help? So you know I'm going to say you're looking for the exponent. What's the base? So what you're thinking is 16 to what exponent is equal to what answer? 2, right? Now I'm going to give you a hint. You ready? If your base is bigger than the answer, then you must have a fraction. Like if your base is big and your answer is small, then your exponent must be a fraction. You ready? So what you're looking for is 16 to what exponent is equal to 2? That is right. Do you know 1/4 means the fourth root, right? And so the fourth root, 1/4 means, what's the fourth root of 16? What number 4 times itself? And you got it. Perfect. Good job. Number 17. Nancy. What exponent? So I'm going to give you an indicator. Now, in this example again, when you're looking at it, the answer's smaller, right? Can you think of and it's a fraction is the answer. So the exponent is going to be negative, because that's what makes that fraction. And what do you think it is? 3 and 27. What exponent? Close. Not negative 1/3, but negative 3 to the negative 3 equals what? 1/27. So what exponent makes it true? And the answer is negative 3. All right, this is Amelia's. You ready? Because I know you got this. Number 18. Can you tell me the answer? 0. Log 1 base 8 is 0. Why?
Because any number to the exponent of 0 equals 1.
So if the answer inside a logarithm is 1, it doesn't matter the base. The answer would always be 0. So when you see a 1 inside the logarithm, the exponent has to be 0 for it to match. Hey, let's take out our calculator. I didn't bring it. Well, then you get to look at my calculator. So, you can take out your Nspire or your 89. I'm going to show both. Do you know that there are times, where there's not a rational answer to this? Like if I said, look here, 5 to what exponent equals 34, you go, wait a second, 5 squared, 5 cubed, like I don't understand. Well, that's because you're just thinking about whole numbers. There could be an irrational number, but how do I find it? And the answer is I'm going to teach you how to use your calculator. So, if I want to evaluate a logarithm with my calculator, how do I do it? You ready? So, old calculators, you have to change the base first and then do it. In other words, there's no button on your calculator for an old calculator that allows you to type in any base and what you have for A inside it. So for our 89, this is what we have to do. Right now the base is B, but there's a simple formula that allows us to change the base to a common logarithm, and we're actually going to change it to a completely different base because that's not on our calculator either. So if you look at our TI 89, do you see any button that says LOG on there? Anywhere. So, there is a logarithm button on your calculator for the 89, but it's a special logarithm that we're going to talk about in a page or two. It's called a natural logarithm. You know, like E is called a natural base? There's a logarithm that goes with E that's called the natural logarithm, and the letters we use are LN, and we say lawn, like mowing the lawn. Lawn, LN. I wonder if you know where LN is on the calculator. Do you see where LN is? And they're always beside each other on a calculator. LN and E to the X, whatever scientific calculator you have, they always are together. Now, what color, obviously, is LN? So if I want it, I'm going to press the blue button first. But I'm just going to tell you that we can use this formula. Instead of log, we can change it to ln and get the same answer. And the only reason I'm using LN instead of LOG is because that's on our calculator face. There is a log button in our calculator, but we actually have to press catalog and then alphabetically get to log or type in the letters LOG, way long, right? LN is right there, we're going to use it. So, I'm going to practice this. I'm going to tell you the Nspires, the new calculators, there's a button that you can type in any logarithm. And I'm going to show you that button, okay? But I'm going to start with the older calculator. If I want to evaluate this, I'm going to change the base. And what I'm going to do is, I can change it to any base and go the answer part over the base. So in other words, I'm going to write this as ln 34 divided by ln 5, and then I can use my calculator. See how I take the ln of what's inside divided by the ln of the base, and that allows us to evaluate it. So can we try that on a calculator? So I'm going to go, which color again? Blue, and then X. Let me just clear all of this stuff so you can see it easier. So blue and then X. Do you see ln that popped up? Then what number do I put in? Now, you got to close the parentheses, and then the divide button, and then again, blue and X. And now what's the other one? 5. Now, if you just press enter, you'll get some weird, long, exact answer. So I want you to press diamond and then enter. And then do you get a decimal answer? So we're going to practice rounding to 3 numbers after the decimal place, because that's what the AP exams do. So 2.191. All right, we're going to practice that. Now, does anyone have this calculator?
I know.
I don't know if this one's warming up. But obviously, do you know where the log button is on here?
It's right there.
Do you see it?
Yeah.
Good. So can you press the control and then 10 to the x? Control and then 10 to the x. What do you notice when you do that? My calculator is still loading up. Do you see an option to put in any base when you do that? Then you just type it in. So the good news is the newer calculators, you don't need to change the base. You just type it in and then go blue, enter, and you're done. We'll see how long it takes to load up. It's like a long time, right? All right. So you press the blue button. So do you see what pops up when you press that blue button and 10 to the x? And then you just type it in. The base is 5, and the inside the logarithm is 34. And then just go control enter. And you'll get the same answer, 2.191. So with the newer calculator, you don't need to change the base. You just press the button and fill it in. That's it. Simple. All right. I need to see, do you know how to use your calculator to evaluate a logarithm? So what's log 98 base 2? So I'm going to go with the 89 to make sure you know how to use it. So you're going to go ln 98 divided by ln 2, diamond enter. Keep going all the way down and use your calculator. Here, ln 4 divided by ln 20. Now, why am I doing this compared to what I did before? Because none of these answers are whole numbers. They're not rational. They're irrational. And so I need my calculator to calculate that irrational answer. So what's ln 4 divided by ln 20, right? And then use your calculator. 22, how would you set it up with your calculator? Ln 2 divided by ln 6. Let's see what you got. Claudia, do you have your calculator today? All right, Davian does. Can you go ln 2 divided by ln 6? What answer do you get? You got it. Just say it. 0.387, right? Be confident. Yes? 23. Dahlia, what would you type into your calculator to evaluate that?
Second log to 225 divided by log 3.
Good. So tell me what that answer is. What? Jessica, can you help her? Yeah, she didn't bring her calculator.
4.92.
Toughy, right? Do you know what happens?
4.3.
Close, right? The 9 makes the, right? The 9 makes the 9, so it's actually 0.930, right? To round it? Tricky one. 24. Who has a calculator there, right? Evelyn, do you have your calculator? Okay, what would you type in your calculator if you had it? Do you know what I always use? You can go 1 over 2, which is a lot more buttons, or just ln 0.5 divided by ln 8, right? Same thing? Evelyn, ask Pedro what the answer is. Cool. Now, here we go. A logarithm with a base of e is called a natural logarithm. We've just been working with it. Ln x base is really, what's the symbol with as a base of e is ln. Here's another example where we don't write down the base. ln means the base is e. We don't have to write e down. ln, how do we pronounce it? Ln. What base is that you don't see? E, but I don't write it down. ln means the base is e. That is called the natural logarithm. It should be called NL, right? Natural logarithm? But no. Maybe it's like French or something. Logarithm de, or Spanish. Logarithm de natural or something. LN. Like that? 25. Don't they flip the things around like that? French and Spanish? Go logarithm de natural? No? I don't know. I was just saying, natural logarithm. LN, it seems flippity. Alright. Hey, can you write each equation in exponential form? So, when I see this, I read it. Ln x equals what? 4. What's the base that you don't see? E. What's the exponent? 4, and what's the answer? X. Again, what base is this that you don't see? E. What exponent is on it? X, and what's the answer? I'm not making this complicated. If you're thinking 100 times over it, it's too complicated. Make it simple. Next one. How about if it's an exponential, how do I write it? Well, what logarithm has a base of e? Ln, what goes inside it? 50, and it's equal to x. And if you practice and you make it simple, it will be simple. 28. What logarithm has a base of e? Ln, what goes inside? X, and what's the answer? Hey, use the ln button on the calculator to evaluate logarithms, right? So, we just did this. Can you just go ln 64? Do you know where that button is? We're not divided. Just go ln 64, boom, boom, answer it. See if you can do it. This answer is 4.1589. Can you use your calculator and get it? With Inspire, do you know where ln is? It's right beside e to the... Well, where is it? Right there. Right? Are we okay typing that in? How about ln 1/3? Can you go ln 1/3 and get an approximate answer? Whenever you're using e or ln, the answer will always be irrational. Because the base e is irrational. So there's not going to be a whole number. You know what the only whole number you get? Is e to the 0 is equal to 1. That's the only one. Turn the page. Hey, that's your homework. Turn the page. Alright, so step 1 for a logarithm. Hey, do you know what a logarithm is? The inverse of n. Good. How many parts make up a logarithm? And do you know how to use your calculator to evaluate it? Or your brain without it, right? Now what we need to learn are, there are properties to logarithms that allow us to simplify them or expand them. These properties follow the exponent rules you learned in middle school. What are those? Hey, if you multiply and the bases are the same, what do you do with the exponents? Add them. If you divide and the bases are the same, you subtract them. If you have one exponent raised to another exponent, what do you do with those two exponents? Multiply them. Those are the same rules right now with logarithms. So what happens if you are multiplying and the base is the same? Do you know I can write them as 2 logarithms and adding? The rule for exponents, if you're multiplying and the bases are the same, what do you do with the exponents? Add them. It's the same rule. We're just applying them to logarithms. So I want you to look here. You have 2 logarithms and what's happening? Adding. How can I write that as 1 logarithm? First thing, are the bases the same? So we write it with 1 logarithm and the base is 3. And then what do I write inside the logarithm? Is I write down the property, which is you multiply what's on the inside. So if the bases are the same and you're adding, what do? I multiply them to write them as 1 logarithm. So that answer really is log 45 base 3. Let's try it again. Do you see 2 logarithms? Yes. Do they have the same base? Yes. What is the base that's invisible? Beautiful. Do you see adding? So I can write this with 1 logarithm, and what I'm multiplying are the inside parts. And you could also write this as log 6x subtract 18. Again, number 3, do both logarithms have the same base? Am I adding? Therefore, I can write it with 1 logarithm. And then what's happening inside? What's going to be multiplied is 4x squared and 3x cubed. So when I multiply that, 4 times 3 is, and then x squared x cubed is x to the, done. How about the other direction? If I want to expand a logarithm, what could I do? So for 72, if I want to expand it, can you think of 2 numbers that multiply to 72? 9 and 8? Break that down. What's 2 numbers that multiply to 9? And then what's multiplies to 8? 2 times 2 times 2. So this could be expanded as log 3 plus log 3 plus log 2 plus log 2 plus log 2. So if you're multiplying inside, how can I expand it? Is by adding. Now, number 5, I don't want to confuse you with number 5, but number 5, if you look at it, are you multiplying or dividing? So, you know what I'm going to do? I'm going to let this one go, because it'll be confusing for me to use a different property. Do you see the property below says the quotient property? We're going to come back to it after we know the quotient property. But number 6, this is an important one. So I'm going to leave it blank and come back to it. Number 6, do you see x squared subtract 4? In order to use the product property, we need a product, right? And when it's algebra, a product means can you factor it? X squared subtract 4, can you write that as a product? In other words, can you factor it? A difference of squares. So how do I do x squared subtract 4? Ladies, are you with me? Yes? Are you sure? So one would be x plus 2 and the other would be x minus 2. And once we have a product, we can write it as 2 logarithms adding. So the product rule. If you are multiplying inside your logarithm, you can expand by adding. If you see adding, you can write it as 1 logarithm by multiplying, right? A property. You'll learn it if you choose to do your homework. Quotient property. What's the rule again when you're dividing? What do you do with the exponents? Subtract. So guess how we're going to expand this is by subtracting. So the quotient rule is, if you're dividing inside the logarithm, how do you expand it? Is by subtracting. So, 8. What two numbers divide to 8? Whoop. Let's do it right. Like 16 divided by... Oh, did I skip one? Well, how about number 7? Do you see subtracting? That's silly, isn't it? Number 7. I don't know what happened. How do I write this as 1 logarithm if you see subtracting? So they have the same base, you're subtracting. So to write it as 1 logarithm, you divide. Now, 6 does go into 96 evenly. Do you know how many times?
31. Oh, 40.
That's right, 16. 6 times 16. So, 96 divided by 6. 16. Let's try it again. So, are the logarithms, do they have the same base? Do you see subtracting? So how do I write it as 1 logarithm? Is by dividing. What's inside the logarithm I can simplify. 8 divided by 4 is 2. Subtract the exponents and you get x to the 8. Number 9. If the bases are the same and you're subtracting, what do I do here? Do you remember how to simplify radicals?
Yeah.
So what's that the same as? Close. What?
Oh, there we go.
8, right? So we could also write that as 2 root 2 if you like. How about the other direction? So I'm going to go back to number 5. Do you see the dividing sign? I can write that as 2 logarithms by doing what? When you divide, how can you expand it? Is by subtracting. So dividing and subtracting, multiplying and adding. Back here to number 10. 18 is 16 divided by 2. So I can write this as log 16 base 3. Subtract log 2 base 3. Number 11, do you see dividing? How would you write that as 2 logarithms? So, I would write down ln 3 subtract ln 4. If you have 1 logarithm and it's dividing, you write it as 2 logarithms subtracting. If you see 2 logarithms subtracting, you write it as 1 logarithm dividing. Here, do you see what's being divided? How would I write that as 2 logarithms? As you would subtract. Alright, next property is called the power property. You remember when one exponent is raised to another one? What do you do with those 2 exponents? Multiply it. So when you have 1 raised to another, you are going to multiply in front of the logarithm. So therefore the exponent inside the logarithm is written as a product in front. You multiply in front. So we can go either direction here. So 3 times log 6. That can be written as log 6 to the exponent 3, which is log 216. So, when a number is being multiplied in front, that is the exponent inside the logarithm. Let's look at it again. Do you see a number being multiplied in front? That is the exponent inside the logarithm. What is 81 to the 1/2? What does the exponent 1/2 mean? Square root. What's the square root of 81? Done. Do you see something multiplying in front of the logarithm? That can be written inside the logarithm as an exponent. Done. So, are you making it simple? Is there a number in front multiplying? That is an exponent inside the logarithm. Here, do you see an exponent inside the logarithm? That can be written in front, multiplying. So where can the x go? In front of the logarithm. Number 17. Do you see an exponent inside the logarithm? Not yet. But what is the cube root? How do I write that as an exponent? Now do you see an exponent inside the logarithm? Where can I write the 1/3? I can write this as 2 to the exponent -6. If I write it as 2 to the exponent -6, where does that exponent go? So, can I remind you of the 3 basic properties of logarithms? These allow us to simplify and expand using the basic exponent rules for middle school. So what was the first rule again? Are you listening to me? This is brand new properties, right? So if you're multiplying, what can you do? Add. And if it's adding, what can you do? Multiply. How about the next one? Inside the logarithm is dividing. So I can expand it by subtracting. If it's expanded and I see a subtracting, I can write it as 1 logarithm dividing. And then the last one is the power property. If I have an exponent inside the logarithm, it can be written as a product in front, or if something's multiplying in front, it can be written as an exponent inside. You are not learning this right now. You learn it when you choose to do your homework and fight through it and think through it and ask me questions, right? Right now I'm introducing something brand new to you. So you're going, I don't get it yet. That's because you haven't practiced it yet. You know what I mean? So we're going to end practicing this together. Properties, properties, properties. There's a very good chance that tomorrow that we won't start with the quiz, but we're going to practice, 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 practice. Get this, right? But if you don't do your homework, you know, it won't help. So, I want to know, what does the word condense mean? Something that's like expand, the opposite, right? You write it simpler as 1. The first thing I look at, both logarithms, do they have a base of 4? Good. So step 1 is, the product in front can be written as an exponent. So where does that 2 belong inside the logarithm? How about the second one? Where does the 3 belong? Where can I write the 3 so it's inside the logarithm? As an exponent. What's 9 squared? What is 2 cubed? Now, how do I write that as 1 logarithm? If I see adding, what do I do with 81 and 8? Multiply it. 8 times 1 is 8, and 8 times 8 is 64, right? Done. Number 20. Step 1. Do you see something in front of the logarithm? And the second logarithm has a 2 in front. Where does it belong? Inside as a what? Okay, what's 4 squared? So, can you identify a number in front being multiplied? Write that as an exponent. 4 squared is 16. Because I'm subtracting, how do I write that as one logarithm? Do you know they go in evenly? Do you have the ability to simplify a logarithm? Number 21, that's what we're doing. These are great SAT questions, by the way. They love these. 21. Do you see any number in front? Of course you do. Where does that belong? Inside as a exponent. Second one too. Inside as an exponent. So can you do step 1? Are you making it simple? Next, apply the exponent. What does that mean? That's p cubed and q cubed. The other one is p to the 4th and q to the 8th. Now, what do I do? If you're adding, how do I write that as one logarithm? And when you're multiplying, p cubed and p to the 4th, that's p to the 7th. Q cubed, q to the 8 is q to the... Done. (22) There is a 1/2 in front, but we need to do what's inside the parentheses before we apply the half. So inside the parentheses, do you see they have the same base in adding? How do I write that as one logarithm? What do I do with what's inside? I multiply them, which means I add the exponent. So it's x to the... You really have to know your exponent rules. Now I'm going to apply it. Where does the 1/2 belong? That 1/2 is the exponent inside. Another way to write this is the square root of x to the 9th. Could you simplify that because you have that skill? Yes, but we're going to move on. So if you had to simplify that, you know that you could write it properly. It's 8, right? If you had to do that, you so could do that. 23. I don't see parentheses. So what's in front of the logarithm becomes the exponent. So can I write those numbers in front of the logarithm? They're in front multiplying. So they belong inside as an exponent. What does that mean? 64 to the 2/3. The cube root of 64. What number 3 times itself is 64? And then 4 squared. So that whole number is 16. And 8 squared is 64. And then subtracting means I'm going to divide. And 16 over 64 is just a quarter. (24) Do what's inside the parentheses first. I have log 15, and I got log 1/9 to the exponent 1/2. The exponent 1/2 means the square root. Do you know what the square root of 1/9 is? 1/3. When you see adding, you multiply these together. What happens when I go 15 times a third? It's like dividing, right? 15 times a third. And then, where does that -2 belong? And what does 5 to the -2 mean? Five squared, but do the reciprocal, right? So it's log 1 over 25. I got 2 more left. And then we'll stop for today. So 25. Can you simplify that logarithm? So start inside the parentheses. That's log 4 squared, which is 16. Then when you see adding, what do you do with the two numbers? You multiply them. I'll help you. That's 512. Then, when you see subtracting, it means you're going to divide. When you see a number in front, it means you do the exponent. So the exponent on 512 is 1/3. That means cube root. Do you know what number 3 times itself equals 512? I know. That's big, right? 8 times 8 times 8. I know. So that's 72 divided by 8. That means this answer is just log 9. All right, one more left. I know we got to keep practicing. The negative sign tells me to divide. That negative sign became a fraction. One more time. We got to practice. 26. So, step 1, 3 over 2 becomes the exponent for A. 1/4 becomes the exponent for 16A squared. I'm going to write this as one logarithm. So, because I see subtracting, what am I going to write down? Dividing. What goes in the numerator is a to the 3/2. Do you know the exponent a quarter means the 4th root? So what's the 4th root of 16 is 2. And then 2 times a quarter is a to the 1/2. So 2 times a quarter is a to the 1/2. Then simplify that. So the bases are the same and you're dividing, so you subtract the exponents. So 3 take away 1 is 2, and 2 divided by 2 just leaves me with a over 2. So 3 over 2, subtract 1 over 2, is just 1. And it leaves me with a to the 1, but I don't need the 1 there. All right, I'm going to do the video for what we haven't done in the lesson, and then we're going to practice. All right, Mr. G Math, over and out.